if x is equal to 3, then find 2x squared. I think this is the one that caused most difficulty. We have to think about our order of operations. We also have to think about what x squared means. X squared means x times x, yeah? So this translated could be 2 times x times x. And we know x is 3, so we have 2 times 3 times 3. And I think if you write it out like that, you would definitely get 18. What a lot of you were doing was you were going, let's do 2 times 3 first and then square it. Get 6 and then square it. No, order of operations. If you're doing it this way, you want to write 2 times 3 squared. You've got to do the 3 squared first to get 9, and that's 2 times 9, which is 18 as well. So you got to square first, and this is the reason. You can clearly see that that translates to 2 times 3 times 3, not 6 times 6 anywhere. All right, and the other one then just led to some negative numbers, I think. In 6, if p is 9, find p minus 3p. So this is 9 minus 3 times 9, I think. That's what 3p means. So I have, don't change the order here. 9 minus 27. It's not 27 minus 9. I go into the negatives, I go as far as negative 18. So I start at 9, I subtract 27, go to the left on your number line. You end at negative 18. So they were the two ones that were a little bit tricky from the starter. There's some terminology we need to be aware of. Let's just short it down to terms. Something like this, when we see something like 2x plus 3y, that is called an expression, an algebraic expression. If I have 2x plus 3y is equal to 7, we've been calling this formula. It's also an equation. What is the difference between an expression and an equation? Max?
Equation has the answer?
Yeah, equation includes an equal sign. Yeah. So expression is just how x and y relate, and then an equation can actually be like a solution. We can get to it. Yeah. So that's an expression and an equation, the difference between those two. I definitely would maybe take a note on this if you would like. If I have a number in front of an x here, that's got a special name. Does anyone know the name for the 2 here? No, you're not going to know. It's called a coefficient. A coefficient is the number multiplying. The number that multiplies is called a coefficient. This number with no letter with it has a special name as well. The number with no letter with it, when I substitute in, never changes. It will always be 7. If it doesn't change, it is something that's called a constant. It never changes. So a number without a letter with it is called a constant. And the letters, we don't call them letters. Because they change, we call them variables. So these letters here, x and y, x, y, a, b, and so on, they're called variables. Some people, just to confuse things, call them pro-numerals. Pro means instead of numerals, numbers. So instead of numbers, we write letters. So, but variables would be the word we use. So variables are the x's, the y's. They vary because I can put different numbers in for them. Substitute different numbers in for x, different numbers in for y. So if I have an expression, which I'll write over here. I'll get out of your way in a second. If I have something like this, is that an expression or an equation? Expression. No equals sign, expression. Which number is the constant?
6.
6. Negative 6, actually. Negative 6. So So this one is the constant. What is the coefficient of b? 3. So coefficient, the number that multiplies, so 3 is the coefficient of b. So that's a coefficient. And this is a coefficient. 3 and 4 are the two coefficients. One is of a, one is of b. How many variables do I have? Two different ones. What are they? A and b. Very good. Okay? So they're just some terminology that we start to use in algebra. You'll be using that terminology right up until, well, if you do maths in university, you'll be using the same terminology. But definitely until year 13 here, you'll be using the same terminology. I came up with this example of where formulas are used in everyday life. This one, does anyone know what this formula is? So I'll write it up here. CF minus 32 multiplied by 5 over 9. Where's that? Where's that from? Oh, someone knows. Let's just give everybody a second to think. I know, Tyler, you're sharp, Tyler, today. Let's have a think. CF. Center forward. No, not center forward. Centrifugal force. No. No. Go on, Tyler. Go on, Tyler. Go on, yeah. Yeah, Celsius to Fahrenheit. Another way, Celsius and Fahrenheit, two different temperature scales. This is how you convert between. So if you have a Fahrenheit temperature, you can convert. So this is for temperature. Very famous formula. So temperature, if we have a Fahrenheit and we want to convert it, so give me a Fahrenheit number that you hear. 99 Fahrenheit. Okay. What's 99 degrees Fahrenheit? So I replace F with 99, take away 32 and multiply by 5/9. Okay, what's 99 take away 32? 67, yes. Fantastic. Well done, Max. You got the best number. And then I multiply it by 5/9. Now we know from our work in fractions that multiplying I can put it over 1 and multiply. Is it 68? No, it's 67. Come on, Zavi. All right, what's 5 times 67? What's 5 times 67? 335? Yes, very good. Over 9. Okay, so I got to divide 335 by 9 to make it this is improper. Let's make it a mixed fraction. How many times does 9 fit into 335? How many times does 9 fit into 3? Doesn't. 33? 3 times. Remainder? 6. 9 into 65? 7 times. 6, 7. So we go into the decimals a little bit. What's my remainder? Or you can put it as a fraction, but we go to decimals. One place of decimals is fine. What's my remainder from 65? 2. 9 fits into that? 2. And it's going to be 2. Repeated decimal. We can put a little dot. 37.2 recurring degrees Celsius. So 99 degrees Fahrenheit is 37.2 degrees Celsius. That's interesting. Maybe it's not. All right. Okay, so we're going to apply some of this now with quizzes, away ground, also for points. So top 10 again.